Hello everybody, in this lesson I will show you how to work out the average gradient between two functions. Now what is average gradient? The average gradient of a curve between any 2 points is equal to the gradient of the straight line joining the 2 points. We use the gradient formula to work out the average gradient between points A and B on the curve. Now, there's a curve for you. This is a parabola, and there's point A, and then there's point A's coordinate. Now, I just want to show you something. This means XA is coordinate, and then FXA. That means it's the notation for the corresponding Y coordinate there at A. And then also you find B and B's coordinate XB, and then this again FXB. This means it's the corresponding Y coordinate of B. Then there's your gradient formula. So you just add an AV here, it means average, which is y2 minus y1 over x2 minus x1. And sometimes you can also refer to it as this. Now it looks very complicated, but you must just understand that this f with a bracket xa is exactly y minus f xb, y, the y at b, over x at a minus x at b. The question: determine the average gradient between points xa is minus 1. That means it's the x coordinate at A is negative 1 and the x coordinate at B is 2 on the curve of the non-linear function of f of x is x squared plus 3x. Now that is a parabola, and you don't have to sketch the parabola. I did it just so that you can understand what we are actually working out. Now to work out the average gradient, we need a x and a y coordinate. So we will start with this a. xa is negative 1. That means the x coordinate at A is negative 1. And to work out the corresponding y coordinate at A, we will substitute into the little function's equation, f minus 1. So this means everywhere where you see an x, you will substitute negative 1. So therefore it's negative 1 squared plus 3 times negative 1, and we find the corresponding y coordinate is negative 2. Therefore, A's coordinate is the point negative 1, negative 2. And then the other coordinate, the x coordinate at B was 2. So to find the corresponding y coordinate, everywhere where you see an x, now you will substitute 2. Therefore, 2 squared plus 3 times 2, and then the answer is 10. That means the coordinate there at B is the point 2 and 10. So when we go to the sketch, the point minus 1 and minus 2 is round about there, and the point B2, 10 is round about there. So we will work out the average gradient between those 2 points, and therefore we will use the gradient formula. And remember now, this fxa, this means the y at A minus the y at B. And then my advice to you is on top of your coordinate, write there x, y, x, y. Then you can't get confused when you substitute in. So when we substitute, the y at A negative 2 minus the y at B 10 over the x at A negative 1, the x at B 2. But remember there's now a minus because of the formula has a minus inside. Therefore, I end with negative 12 over negative 3 is 4. Therefore, the average gradient between those 2 points will be 4. Let's do another example. Calculate the average gradient between points A negative 1 and we don't know what the corresponding y coordinate is there at A, and B, the point 1, and again y is unknown. On the curve of the function, h of x is equal to 4 over x minus 3 plus 2. Now this is a hyperbola. You don't have to sketch it. I sketched it for you, just so that you understand what we're doing. So first of all, we need to calculate the corresponding y coordinate there at A. And I will do that by substituting in x's place -1. Therefore, 4 over -1, -3 plus 2, and the corresponding y coordinate is 1. Therefore, A's coordinate is the point -1 and 1, and add x, y for yourself. And then also the corresponding y coordinate at B, we have to calculate that one. Therefore, h of 1 is equal to, and everywhere where you see an x, you will substitute 1. Therefore, it's 4 over 1 minus 3 plus 2, and the corresponding answer is 0. Therefore, the coordinate at B is the point 1 and 0, consisting of a x and a y. Then, the average gradient, there's your formula, fxa minus fxb. And remember, this is the exact same way of writing the y at A minus the y at B. And then we can substitute. The y at A is 1 minus the y at B is 0 over the x at A is -1, the x at B is -1. And the average gradient is -0.5. Example 3. Sketched are f of x is 4 over x plus 2 plus 3 and g of x is half of x plus 5. Determine the coordinates of C. So what we need to do is we will have to look at the sketch and see what is happening at C. And can you see it is the place where the two graphs intersect, and therefore we will use simultaneous equations. Now what I want to say is the third question of this one will be to find the average gradient, but now they will lead us to first finding the two coordinates that we're going to use to work out average gradient. So first of all, coordinates of C. As I said, it's the place where the two graphs intersect, therefore we will use simultaneous equations. And we will say 4 over x plus 2 plus 3 equals half of x plus 5. We equate the two graphs. Then here the plus 3 will walk across and it becomes -3, and then 5 -3 is 2. Then I find the LCD, and the LCD is 2 bracket x plus 2. And what do I do with the LCD is I will multiply every single term by 2 bracket x plus 2. Even this one, 2 bracket x plus 2, and this last one, 2, let's put it in a bracket, x plus 2. And then x plus 2 and x plus 2 will cancel, and I'm left with 2 times 4. And here the 2 and the 2 will cancel, and I'm left with, you can see it there, x bracket x plus 2, and on this one there's your 2 bracket x plus 2, 2 and a 2, x plus 2. Now in the next step I will multiply out the brackets. 2 times 4 is 8, x times x is x squared, x times 2 is 2x. And then for this one I said 2 times 2 is 4, and then you will multiply in the 4. 4 times x is 4x, 4 times 2 is 8. Then I will add 2x plus 4x is 6x, and then this 8 will walk across and it becomes -8. So I end with 0 is x squared plus 6x. And now I will factorize. I will take out x as a common factor, and I'm left with x bracket x plus 6. And x is equal to 0, or x is equal to -6. Now, I was really pleased that I ended with 2 x values, because if you look at the sketch, you can see that your two graphs intersect there at C, but there's another place there at 0 and 5, and I was very pleased to see that the 1x was indeed a 0. And then obviously the x at c is negative 6. And then now I have to work out the corresponding y, so I will substitute x is negative 6 into g of x. Remember, you can substitute into either f or g, but g looks easy, so I chose that one. In x's place goes negative 6, so half times negative 6 plus 5, y is negative 3 plus 5, the y is 2. Therefore, the coordinate there at c is the point negative 6 and 2, which I will use later to find the average gradient. Well, now I have the coordinate c, negative 6 and 2. So the second question here says, determine the coordinates of d to 2 decimal places. Now, what is happening there at d, that is the x-intercept of your hyperbola. So can you see how they test all your knowledge here? You must understand x-intercept make y 0. So we will take, and can you see it's the hyperbola? So into the hyperbola there, in y's place, I will substitute the 0. Then the plus 3 will walk across and it becomes negative 3 equals 4 over x plus 2. Then I will find an LCD again, x plus 2. And then what I do with the LCD is I will multiply both sides by the LCD. Here x plus 2 and x plus 2 will cancel, and I'm left with negative 3 bracket x plus 2 is 4, and then in goes the negative 3x minus 6 is 4, and I will solve for x. The minus 6 minus 4 is 3x, minus 6 minus 4 is negative 10 is 3x, divide away the 3, and therefore the x coordinate at d is minus 3,33, and I know that the y coordinate there was 0. So now this question says determine the average gradient of f between point C and D. So can you see the two previous questions led you to find the coordinates of the 2 points C and D, and you had to use all your previous knowledge. Now, let's see. Average gradient, there's the formula. Y of D minus Y of C over X of D minus X of C. And there's your 2 points, your 2 coordinates. And I will rather write X and Y on top of that, so that I don't get confused when I substitute. Therefore, the Y at D is 0 minus the Y at C is 2 over the x at D is minus 3,33 minus the x at C is negative 6. And then when I work that out, on top 0 minus 2 is negative 2, negative 3,33 minus 6 is 2,67, and the average gradient 1,92. Thank you for watching. I sincerely hope that you watch all 16 videos on the parabola. In the next video, you will find the hyperbola. Click on the video in the left-hand corner to take you straight to the next lesson. Goodbye.